Good afternoon, ladies and gentlemen. We're here at booth number L1200. In about 10 minutes, we're going to proceed to the IC Taiwan Grand Challenge with SEMICON Taiwan. So if you have registered or you have not registered, please feel free to join us here at booth number L1200. We're here at a purple stage. And we're about to have the IC Taiwan Grand Challenge with SEMICON Taiwan at 2 o'clock. So please move your steps to join us here at booth number L1200. Thank you. Ladies and gentlemen, the IC Taiwan Grand Challenge with SEMICON Taiwan will commence in 1 minute. So please kindly take your seats. Thank you.
Before we muster the courage to take the first step, no one imagined we could go so far. We found answers in this small flint. Before enlightenment, no one knew the flint would ignite the hope of human civilization. Let us no longer fear when facing the capriciousness of nature. Let us endure the test of life. We are determined to push beyond the limits of physics, to shatter all ingrained perceptions. Taiwan, the island of semiconductors, we would not hold back. Gather all our strengths to empower each other. Together, we stride towards the future of semiconductors. We respond to the trust given by every international partner. Here resonates the truths and inclusivity we earnestly seek, pursuing sustainable development across generations, guarding love and freedom with justice, creating miracles with a spark of inspiration, persisting in faith, seeking another kind of harmony. The future lies in your hands. We stand here, continuing this blueprint of a brilliant future. I see Taiwan, I see Grand Challenge.
I see Taiwan, I see grand challenges. Ladies and gentlemen, our distinguished guests, and of course our startup partners on site and also online. Welcome to join us here at I see Taiwan Grand Challenge with SEMICON Taiwan. I'm your MC today. My name is Rebecca. And in the very beginning of today's challenge, I'm very honored to welcome our first guest to join us on stage to give us a few words. So I would like to welcome Vice Minister of National Science and Technology Council, Dr. Zheng Gang-Su, to give us an opening remark. Welcome, Dr. Su. Please join us on stage for the opening remark. Welcome.
SEMI 台湾，听说他们说今天有同步翻译是吧？
有，我们在荧幕上面这边，等一下就会出现。对，
我们曹全球行销长曹总裁，还有我们的召集人杨召集人，以及2位张委员跟吴委员，今天来帮我们看今天所有新创的案子那事实上这几天在SEMICON 台湾，我们发现到今天最后一天呢，还是人山人海还是非常的这个热络。那事实上，半导体跟 AI 让台湾现在是全球站在风口浪尖上面那趁着这个浪呢，我们也希望让百工百业都能够来运用这个 AI 跟智慧科技。所以我们不只要让台湾能够有硬体的研发能力，也要希望能够让台湾未来在软体跟系统整合上面都能够具备一定的能量。那另外就是希望让这个智慧科技跟 AI 的发展能够普及到所有的行业， 让大家都能够感受到这个技术进步的能量哈。所以我们今天在全球展开了 IC 台湾 Grand Challenge 这样的一个 program 哈，不止在这个 SEMICON 台湾，我们在这个同时在德国的 IFA， 还有未来在杜拜的 GTEX， 以及明年的 CES， 我们都有同样的 IC 台湾 Grand Challenge 这样的一个全球展览。那希望让透过这个计划呢，能够招募到很多新创的团队，很多人才能够到台湾来发展，不管是在半导体跟 AI 方面。那我借这个机会代表国科会感谢我们几位委员，还有我们召集人以及 Terry 在这几天真的是忙翻了，这个全球的目光都在这个地方。我们希望能够借由大家的能量，让我们找出优质的团队，不管是在地链接也好，或者是在技术创新也好，甚至是在价值创造也好，能够让百工百业都能够普及。那最后我代表国科会预祝今天的活动顺利成功，然后大家身体健康，万事如意。谢谢各位。
谢谢 ，Thank you so much, Dr. 郑刚苏 Thank you so much. And right now, we'd like to welcome Mr. Terry Cao, the Global Chief Marketing Officer and President of Taiwan at SEMI, to give us a few words. Welcome. Okay. 没有声音，好。
线上的朋友听不到，对，喂，有，是，副主委，杨总召，各位委员，我们的这个副处长，各位新创团队，还有各位线上的朋友哈，大家午安。我想我们就是 SEMICON 的这个主办单位哈，在此也是诚挚的欢迎各位哈。那诚如刚刚这个副主委提到哈，今天是活动第3天哦，那还是有很多的人。但对我们来说，不管前2、3天做了什么，好像很厉害的那种大师论坛哈，但对我们SEMI来说，我们一直很关心的就是说，对于一些下一个 generation 对产业的一些发展，不管是人才或者是新创的团队，其实这个我们的杨总召哈，其实在去年还有前年，是去年吗？对，去年对不对？就是我们现在在那个展览馆的对面哈，同场正在举办另外一个是研发大师论坛，就是我们杨总召去年参加的这个论坛哈。所以就说我们其实 parallelly 我们在谈研发大师跟所有那边很多的年轻的学子，好，那在这个地方我们充满了各种新创的团队。那我觉得这才是我们整个的半导体行业啊，或者是 AI 运用的行业，能够继续有新兴，就是生生不息的火苗，可以让产业做永续的一个发展。好，那所以我们非常乐见有这样子的一个活动，特别是我们政府哈，在国科会从去年的这个计划到今年，把整个的这个精创计划能够把它落成哈。其实产业界有很多的声音。大公司说应该精创计划都会是资源在这个大公司上哈，但我想我们国科会也非常的就是认为说，鼓励新创才是让产业生生不息最重要的一个这个种子哈，所以我们代表产业也是十分感谢整个国科会在精创计划的一些使命跟这个愿景哈。那我转过头来也是要鼓励各位新创团队，我们希望透过这样子的平台。各位的这个很好的 idea， 可能可以透过精创计划能够实现，而且能够跟台湾强大的这个半导体跟这个资通讯行业能够做紧密的结合。不但帮助你们的企业成长，也同时让台湾的这些 ICT 跟半导体行业在世界上面，或者是跟各位的新兴的行业上面，成为不可或缺的一个重要伙伴。好，那我想最后。预祝这次的活动成功，也希望各位青创团队今天都能够得到我们的总召跟这个各位评审的这个青睐。好，谢谢。
Thank you so much, Terry, for the wonderful remarks. And please kindly take your seats. And right now, in the very beginning of today's IC Taiwan Grand Challenge, we'd like to invite our guest of honors to join us on stage for a group photo. 我们现在邀请贵宾呢到舞台上，跟我们先进行一张大合影。So first of all, once again, we'd like to welcome Dr. Zheng Gangsu, the Vice Minister of NSTC, to join us on stage. Thank you so much. And also, once again, Mr. Terry Tao, the Global Chief Marketing Officer and President of Taiwan at SEMI. And also Mr. Conrad Yang, Chairman of the IC Taiwan Grand Challenge Jury. Please join us on stage. And right now, I'd like to welcome our judges. Judge Shi Zhongzhang, please join us on stage. And also Judge Xue Lanwu, please. And also Judge Eric Zhang. Thank you so much, our judges and jury, of course, and our honorable guests. All right, and right now, we'd like to ask all. Okay, all right, thank you so much, and please kindly take your seats. 我们也请小心台阶，来帮我们先回座。我们谢谢所有的贵宾，感谢，我们小心一下阶梯。哎，谢谢，我们请先回座。All right, so after the group photo, right now we're going to move on to the Global Startup Pitch session. And before we begin, let me briefly explain the rules of today. So each team will have 4 minutes for the presentation, and followed by a 4 minutes Q&A session from the judges. And because the time limitation, so during the Q&A session, please answer the question briefly. And when there is 1 minute left, we will have our staff raise a sign in the back over there so you know the time. And so please be mindful of the time today. And right now, ready? We're going to welcome our first team today. Please welcome Blue Shift Memory.
Hello, I'm Helen Duncan, Chief Marketing Officer of Blue Shift Memory. We're a fabulous semiconductor IP company based in Cambridge in the UK.
Probably bring the mic up a little bit. Yeah.
Okay. Our mission is to speed up memory-hungry applications in all kinds of computers while we reduce energy consumption. Big problem in the world today. This is not just for AI. Lots of other memory-hungry applications like large simulations, in-memory databases, and we also have applications in automotive and mobile communications as well. We're addressing the well-known problem of the memory bottleneck. This is the phenomenon that memory advances have not kept up with processor technology. They haven't kept up with Moore's law, and the gap is increasing year on year. We've reached the stage where CPUs can remain idle for up to 80% or even more of their time, just waiting for the data they need. And that is consuming unnecessary energy as well. Conventional AI solutions don't speed up the calculation. They speed up the calculations, but they don't solve the fundamental problem of getting the data there in time. Our solution is hardware benchmarked on FPGA, give zero latency between the cache and the core, 300 times speed improvement, and up to 90% energy reduction. And that's on an FPGA, so if it was in silicon, we would expect a much better acceleration. Okay, our IP can be integrated into the memory and into the CPU. It works best if it's in both, but we can get significant improvements if it's in the CPU or the memory alone. What we do is we replace the cache with what we call Yonder, and that makes sure that the data is there before the processor needs it. So our self-optimizing memory understands the application workloads and adjusts the data delivery accordingly. It's also inherently secure, but we're working on a quantum resilient option as well. the graph, which you may not be able to see too clearly, the red columns, they're conventional Harvard architecture. The blue columns are the clock ticks and data traversals with our architecture. So you can see why it's speeding it up and where the energy reduction is coming from. We can extend the product life cycle of older DDR generations, so we can make DDR3 compete with DDR6. We are also memory cell independent, so we can work with HBM, MRAM, FERAM, SRAM, even SSDs. So this is our product roadmap. We're on FPGA at the moment. We're also working with a RISC-V vendor to integrate our IP into their processor. And we've done all that on a grant from Innovate UK. We're now looking for seed funding to work with a Taiwanese memory vendor to integrate our technology into their new HBM2 design, which will be going to market at the end of next year. And then further down the line, we would be looking to integrate into DRAM and HBM more widely. It's well known how big the memory market is. We're only selling the IP, but that still gives us a served obtainable market of around £1 billion in 2028. We've put together a formidable team who between them have over 100 years experience in the semiconductor industry. We've also got experts in supercomputing, mathematics, and in deep tech startups. And our core team between them has a combined total of 6 exits and 22 patents. And over on the right-hand side, you can see the impressive list of companies that our team has worked for in the past. Just to summarize our achievements, I mentioned the grant which funded our demonstrator development. We've also received awards, Most Innovative Memory Architecture at Flash Memory Summit in 2023. We were part of the UK's Chip Start incubator, which finished in the summer. And we've already accepted a place at Taiwan Tech Arena South as well. The bit at the bottom, I've already explained that. Okay, we're looking for investors to join our seed round and partners who are interested in extending our ecosystem. Thank you very much.
Thank you so much, Helen from Blue Shift Memory. Please remain on stage. Yes, and now it's time for the judges to ask questions. So, judges, you may proceed.
Hi, thanks for the presentation. You mentioned that you're working with the RISC-V
Yes.
CPU, sort of like a vendor. Are you also talking to ARM or like other
Potentially,
Yeah,
in the long term, we could work with ARM, Intel, Apple. The reason we're working in RISC-V is because it's an open architecture and we're allowed to modify the instruction set. At the moment, although ARM says it's customizable, they don't allow us to modify the instruction set.
Okay, thank you.
Okay.
Thank you. Any other questions? Okay.
Any current business you are cooperate with Taiwan's any firm?
Yes, I can't name them at the moment, but we hope to have an announcement out in about 6 weeks' time. We have submitted a joint CRD proposal for the bilateral grant. So hopefully, if we're successful for that, we'll make a big announcement about it.
Follow up the question. You have an office in TTA now already?
We haven't moved into the office yet. We're waiting for funding to recruit an engineer to work there.
Okay, good. Thank you.
There are a few memory designers in Taiwan too.
Yes.
And what is your plan to Number one, how do you benchmark with, say, the potential competitors in Taiwan and your collaboration plan? Can you say a bit more?
Okay. Although we do have competitors, they are not direct competitors. In fact, the beauty of our technology is that it can work with other non-von Neumann technologies. So for instance, in memory computing, we can make that work even faster. And even neuromorphic computing can be accelerated by our technology. The only one we can't accelerate is photonic computing. So yeah, that's why I said we're looking for partners in an ecosystem, because we're not trying to take market share away from anyone else. We're trying to help all the people who are already working in it.
All right, thank you. Any other questions from the judges? All right, then, thank you.
Thank you very much. Thank you,
The Blue
everyone.
Shift Memory for your wonderful pitching. Thank you, and please kindly take your seats. Thank you. All right, now we're going to welcome our second team to the stage. Please welcome Quantum Diamonds.
Hi, I'm Fleming. I'm a CTO of Quantum Diamond. We're a Munich-based tooling company, and yeah, we're developing an inspection tool for failure analysis. So the chips we're typically working with right now are advanced packaging chips. We've worked with backside power delivery chips, and also wide bandgap semiconductor chips. And a general problem with these in failure analysis, especially the first two, is many of the failure analysis tools used right now, like lock-in thermography or laser-induced techniques like Oberge, are optical techniques. So they cannot penetrate metal layers. They have a very limited depth resolution, and especially for advanced packaging and backside power delivery, there's metal layers everywhere, and depth resolution and looking at deeper structures is essential. So our solution to this is to look at magnetic fields produced by active devices, so the currents in an active device. The magnetic fields produced by these currents penetrate the IC and the packaging unperturbed, and we can then analyze the magnetic field by a quantum sensing technology using defects in a diamond lattice. So we place a diamond very close to the sample, and we can then collect fluorescence from this diamond, fluorescent red light, with a camera which contains the information. This is an example of a measurement done by one of our colleagues. This is an Infineon chip, so the length scale is here about 100 by 100 micrometers. And this is like how resulting data looks like. We get magnetic fields in X, Y, and Z direction. And then we can also post-process these data to reconstruct currents within each individual layer of the IC. So in this case, in the upper line, for example, you see a working device, and in the bottom line, this is a failed device. There was a short, and you can easily see it within the magnetic fields, but you can also see it in the current reconstruction here. Yeah, so I mean, notable things. We can 3D reconstruct current flow in ICs. We have lateral and depth resolution that are below a micrometer, and it's room temperature. So it's at the ambient temperatures, ambient conditions. There have been magnetic imaging devices before, but most of them used cryogenics or similar stuff that's uncomfortable to handle and typically also very expensive. This is also to emphasize again the depth resolution. So this is a 3-layer IC that we just used to test, and this is basically the raw data that we get in one of the magnetic field directions. We can split this up into the magnetic fields produced by each individual layer, and then reconstruct a current from each individual layer, look at them, look at defects in them, yeah, and do analysis. This is a slide demonstrating or explaining a little more on the resolution that we have. So it tends to be a little bit depending on the depth of the corresponding layers that we look at. So the deeper down they are, the worse the resolution gets. This has just to do with the propagation of magnetic fields. Typically, it's about 10% of this distance to the surface from the respective metal layer. So typically at the moment we've been looking at metal 6 and above, and micro bumps between individual dies, or dies and interposer. At the moment we do proof of concept testing, so we've been working with 6 out of the 10 biggest companies in the semiconductor industry with initial tests. We're starting to sell the first device this year, so basically in the fall of this year the first devices will come on the market. Yeah, and we of course do maintenance on those. That's it. If you want to talk with me and any more additional information, you can also visit us at our booth in the other building, 4th floor, at the Bavarian Pavilion. So, yeah. Thank you.
All right, thank you, Flatman from Quantum Diamond. So it's time for judges to ask questions.
I'm just curious. You are going to Taiwan. Taiwan is a customer base or collaboration base or whatever, or do you need any help from Taiwan?
So yeah, I mean, it's mostly a customer base. We've been talking with various companies and also like research RTOs here on either like demonstrating our technology, understanding better the customer needs, especially with like regarding speed and resolution, depth resolution. We're a young company, so we're trying also to figure out what kind of KPIs we have to focus on first. There's a lot to do. One of the things that we're also really interested in is also moving towards AC currents. We can measure currents up to 4 gigahertz, which is interesting for various reasons, also like increasing the resolution. But yeah, for Taiwan, it's mostly customer base.
Thank you. Other judges?
Okay. Any collaboration plan? Okay. You mentioned it's customer base.
Yeah.
But in the near term, any collaboration plan with the industry here?
I mean, we've mostly been talking with Taiwanese RTOs also on collaborating on understanding better how we can help with TSVs. So one of the benefits of our technology versus other magnetic imaging techniques is that we can image vertical currents. So we are at the moment also starting to look into if we can help with imaging defects and voids in TSVs. That's one of the collaborations we're talking about right now.
Okay. Yeah.
Well, follow up the question. If you got a lot of traction from customers, are you going to do a production in your tour in Germany or? Okay, so it's pretty much all the.
We're collaborating with a German engineering company who has been doing tooling production for various other semiconductor companies. So yeah, we're producing in Germany and in Europe.
Okay.
Yeah.
Can you share the testing progress and the results from your partnership with semiconductor manufacturers and all others?
So like most of the data that we collected there is NDA protected. We have brochures though that we can also hand out with public domain ICs where we can like where both the layout and everything is public domain. Yeah, so we can share this with you if you're interested. Yeah.
One question.
Yes. So, what's the roadmap for like future development? In the sense that, I mean, do you foresee that, for example, all these technologies that's gathering new signals, right? Are you like going to go into the analytics, or is it more focusing on the instruments?
Yeah. So there's a lot of things to or features to add in both the hardware capabilities. What I mentioned already is imaging of AC currents. There's a lot of benefits, a lot of ways we can apply this to get more information out of a device. But there's also a lot of room still in post-processing, especially increasing resolution. At the moment, our lateral resolution, the best one that we can achieve is around 200 nanometers. But we think we can go down a factor 4 there, which is quite a lot for a failure analysis tool. So typically, localizing a defect is more on the single-digit micron range, and you're really good already. So yeah, it's both in the post-processing area, but also for like hardware features. We're planning a lot in the next 3 years.
So are you like working with any academic research universities, like providing tools to give like professors essentially another tool to doing this kind of research?
We're in a close collaboration with the Fraunhofer Institute in Germany, so
Okay.
various of them. We're ourselves are a spin out of the Technical University of Munich. So the sensing technology comes from Technical University of Munich. Yeah, and we're also talking with ET right now, as I mentioned, for example. Yeah. Okay.
Okay, any other questions from the judges? All right, so thank you so much, Quantum Diamonds, for the presentation. Thank you.
Thank you.
And next up, I would like to welcome Silesium Circus, please. Welcome.
Hello. Very good afternoon, SEMICON Taiwan. My name is Rijin John, and I am one among the 1.4 billion people in India, and I represent the most promising semiconductor startup in India, and I am one of the startups handpicked by Taiwan Technical Arena, TTA, and NSTC for the India-Taiwan Exchange Program, and we are one of the startups that is supported by both these NSTC, TTA, to have a booth in SEMICON Taiwan. First of all, thank you so much. Yeah, Silesium Circuits, we are primarily a semiconductor IP company focusing mainly on analog, RF, and mixer signal. To put it very simple, we connect the unconnected devices. We are into the wireless domain. We focus on connecting interconnected devices through the air interface. This is the co-founding team. The other co-founder, Dr. Arun Ashok, he was formerly working with the semiconductor laboratory in India, who has done his master's and PhD from Aachen University in Germany, who's the CTO, takes care of the product and technology, based out of Germany, taking care of Europe market. My name is again Rijin John. Though I am from a tech background, I take care of the strategy, sales and marketing, the business side of Silesium Circuits. We have a strong lineup of advisors who's helping us through our journey forward. This is our aspiration and reflections. Our vision is to catalyze the world into semiconductor prowess, and these are the goals that we have for 2025, 2030, and 2035. So to replace the RF IP imports in India by 2025, to become the largest RF exporter from India by 2030, and to be the most sought-after analog brand by 2035. And we, being a fabless company, we are working closely with the semiconductor fabs in India. I'll come to that in detail. So the roadmap for our strategy going forward is to have the design team for the legacy products in India, and to set up an office with TTA South for the cutting edge technologies going forward. This is the business model canvas in brief. We have close connection with almost all the semiconductor fabs in Taiwan, and the customer segments, revenue streams, and key partners are also identified. These are the revenue models, and we have at least one customer in almost all these revenue streams that we have. So we have the B2B and B2G segment, and this is very specifically on the semiconductor IP roadmap. These are our core competences, one step in depth. These are the focus sectors that we have, and we have at least one confirmed customers to start with all of these products in pipeline. This is our IP and SoC roadmap. We started with the front-end module for GNSS, which supports NAVIC, GPS, Galileo, all of those. We have designed it, and we have a successful tape-out, which is done with TSMC Taiwan. So I would say we do the design in India. This is our first baby. We designed the baby in India, and the baby is delivered through the fabs in Taiwan. This is the total market size that we are looking forward to capture, maybe a percentage of it, which includes all the wireless components that we are in pipeline. These are the rough traction when it comes to the funding. We are bootstrapped. We have close to around 4 million commitment from the Indian government, and we are still working more on that side. These are the other grants in pipeline. Go-to-market and exit strategy is pretty much clear. In long run, we have the GNSS, analog RF, and also the digital, and oh, sorry, there is a typo, that is IPO, not IO. And we see a more potential to get acquired even before we go for an IPO. This is one unfair advantage. We as a company focus only on the wireless domain. We have partners in Taiwan in other domains where we play our strength, which is semiconductor wireless IPs. Anything else, we partner and collaborate with other potential partners so that we can move fast, scale fast, time to market is pretty fast. This is the trends, acquisition trends in India. We are partner to almost all the companies, either in terms of the IP level discussion or at the SOC level discussion. This is the global acquisition trends. And we are open to partner with multiple entities, which includes the baseband, digital, or anything related to the other semiconductor related ecosystem in Taiwan, which we are already discussing through TTA and related entities. That's all from our side. Thank you so much for this wonderful opportunity.
Thank you so much, Rijing John from Silesian Circuits. And now it's time for judges to ask questions.
Thanks for the presentation. You mentioned that you want to replace imported analog RF. So are you building products that are essentially existing already, or do you have any like new differentiating sort of like technology or like differentiators in terms of the product that you design or the IP that you create?
Yep. There are two parts to it. There are a lot of existing IPs which is already there, the legacy IPs. So we are developing those legacy IPs with a better performance, power, and area. That is one thing. Another thing is we are also looking at, for example, automotive sector, which has got a long gestation period of 5 years. So we are parallelly working on those kind of IPs, either from a Silesium India perspective for the key components that we have already developed, or with a partner, potential partner in Taiwan who can complement this to cut short our time to market. This is the strategy that we have. Did I answer to your question? Thank you.
What do you see as the strengths, okay, in terms of analog RF in Taiwan that you can leverage other than, you know, the manufacturing capability? I mean, in terms of design capability, what would you like to leverage in the future?
Yep. Thank you. Good question. The strength that we have, or the way we look at it, is even when we say analog, RF, and mixer signal, that's also an ocean. So there are a few areas that we are very good at it. So we focus on that. And there are also analog, RF, and mixer companies in India with whom we are connected. And we are collaborating with them to take things pretty faster. Yeah. For the existing ones, that is going to be the strategy. For the new ones, there will be a joint development program that we are planning so that now both the skill set and both the expertise can come up with a product which has a cutting edge in future. That is the rough strategy that we are planning. Yeah.
The strength of Taiwan, you would like to leverage?
Yeah. The strength of Taiwan, I would say you have everything here. Yeah. You are in the pool of luxury of having anything related to semiconductors. Yeah. Right from the talents, right from the people, the fabs, the foundries, the packaging, testing, post-silicon, good people, supporting people, good food. Yeah, so Taiwan is a lot to me, you know, from my short experience. So I think there is a huge potential in collaborating with the entire Taiwan ecosystem that we have, not just on semiconductor IPs, but definitely the way forward. Yeah, I see that. Yeah, and we are already in discussion with the analog RF IP companies here as a potential partners. Yeah, we are. Yeah.
I couldn't see very clearly about your competitive advantage. You have one page showing that. Yeah. Can you go back to that page? Oh. Anyway.
Yeah. So can I explain to that?
Okay.
So,
let me just elaborate a little bit. Mixed-signal RF IP has been a long time industry from US. Taiwan has a little bit. Taiwan probably not a leading one. There are a lot of competition in this area. What is the real advantage? Are you talking about your Indian market? I can imagine that could be the only advantage you have, the other people don't have. The technology-wise, I couldn't see clearly what you really have other people don't have.
Yep.
That's
Thank
my
you.
question.
Yep. Yeah, let me take this as a very simple example of highlighting our USP. The chip that we have designed and tape out and tested, the performance of that particular chip is better than 4 other international brands. Yeah. So when we say there are a lot of brands existing or lot of products existing, there is still a lot of opportunity if you are innovative, if you can come up with something in terms of technology. Yeah, not about the price. Specifically looking at the market, so definitely Indian market is something we want to capture because of the change in the dynamics. A lot of companies are coming in India, and that actually opens up multiple opportunities for us as a startup to start with. And then through those original equipment manufacturers, ODMs, we can also capture to their customers and then plan for a larger canvas directly as an individual company. We being just a 3-year-old company, there is a limitation to which we can target to a larger audience. We have an IP distributor in Taiwan who is also helping us a lot of in the IP distribution space. So like I shared earlier, we can't be everything to everyone. So we focus on what we are and collaborate with potential partners to explore our strength further and navigate in that particular journey. Yeah. So specifically on the product side, yes, there are a lot of existing products. If you look at the vehicles, we had Toyota, we have this, now we have more new brands coming up, Tata, Toyota, Tesla, and a lot of, so there is scope for any startup to come up and excel if your product has something innovative and unique that will add value to your customers. That's my humble submission. Thank you.
Any questions from the judges? All right, then please give a round of applause to thanks Elysium Circus for the presentation. Thank you.
谢谢，谢谢。
谢谢. Thank you so much. And last but not least, we'd like to welcome our next team. Please welcome Wise Integration. Welcome.
Hello everyone, thank you for the invitation. So I'm Florian Couvin, so co-founder of Wise Integration. We are a French tech company based in France and in Asia. So we have almost 5 years of existence, and now we have close to 25 employees based in France and in Asia. We are a fabless company. We design chips and we sell chips to system makers. We are working as a fabless company with TSMC in Taiwan, and we are working on our new materials for energy transition called GaN. GaN stands for gallium nitride. Gallium nitride is a key enabler in the whole energy transition, especially to feed all these electricity demands. So we are working with TSMC as a fabless company and ASE Group for all of our packaging strategy. And we have a strong financial support from our investors, both from Europe and also from Asia. Yesterday, we announced a key interesting in the news. So we welcome Apply Material Venture and ETIC from Taiwan joining Wise Integration Adventure. I'm very happy about it. What we do is building the 2 key chips in an AC to DC power converter to make them more compact and more efficient. We are building the brain and the muscle of the power supply. The brain is a software which is implemented into a standard MCU microcontroller, and the muscle called WiseGaN is a switch made of gallium nitride. And we sell these two chips to ODM, or original design manufacturer. All of our customers are requesting the same, making more compact, make more fast charging and efficient power converter from consumer applications for compact adapters up to big power supplies for server, especially to feed AI demand. So we are addressing these challenges through our two key chips. 4 main targets of applications, from consumer up to automotive industry in the future, but at this moment mainly focused on consumer applications for compact adapter, also for TV, for monitor, this kind of applications, up to AI server, because this is where we need to bring this kind of new chips. This is the portfolio of our WiseWare digital control with our software inside. So one software is managing a dedicated topology of power conversion. No need to dig too much in details, but yeah, one control, one software for different kinds of applications and power ranges. Very scalable business model. Standard MCU with proprietary software inside. Yeah, too much details, but we are bringing evaluation boards to customers because they are requesting boards in order to help them moving forward in their developments. So we do also hardware to prove that our software and our chips are working together perfectly. This is our portfolio of GaN power device, so called WiseGaN, switches made of gallium nitride with TSMC design kit. Generation 1 is released. We are starting promotion now, especially in Asia, with our office in Taiwan. So we are bringing this into the market now, and we are starting making business now after 5 years of existence. This is our second generation of our GaN product portfolio. It looks like, actually it looks simple. However, in GaN, you don't have the CMOS technology. We don't have the P channel. So this is much more complicated to achieve in terms of design as a fabless company. As a fabless company, once again, we sell chips and we sell software into a MCU, microcontroller. For the software called WiseWare, we develop the firmware integrated into a standard MCU. And for the GaN switch, we design as a fabless company. We use TSMC and ASE Group for the package, and we sell these two chips to ODM, like Delta, Lite-On, Chicony, Yakabel for the Taiwanese players, through our distributors, and they will make the power converter for their OEM. Sales channel, as a fabless company, we sell chips to our distributors, very simple standard business model as a fabless company. We have been investigated very actively over the past 4 years now, the Asia market, because this is the place to be. We manufacture here in Taiwan, and we sell actually here in Taiwan, but the design is made in France. So yes, we are actively looking for new players for joining us into this adventure. And now, last, this is the team, strong team with lots of experience, both for semiconductor activity and also for startup development company. And we are accelerating the whole energy transition thanks to our new device, but also with our control, which is the key differentiator we have competition. Thank you.
Thank you so much, Wise Integration, for the presentation. And it's time for the judges to ask questions.
A quick question. Are you a TSMC customer? Are you on the customer list already?
Yes.
Okay. So since you are in the customer list, what else do you need help from Taiwan?
Good question. We manufacture and we sell in Taiwan, and this is key for us, and I'm very glad to work with Taiwan. It's going good so far over the past almost 4 years now. We are expanding our company here in Asia, but mostly Taiwan. We have an office also in Hong Kong. I don't expect so much actually for now. We now welcome new investors from ETIC into this huge adventure, and just trying to expand in Taiwan. So everything has to be accelerated, and yeah, we need to deliver the products and move forward.
So you already have an office in Taiwan?
Yeah, we have an office, thanks to Garage Plus, by the way, from APOC Foundation.
You mentioned, if I heard you correctly, you mentioned Delta Electronics, Lithium, okay, these power electronics related companies. How do you benchmark your innovations as compared to the existing products or technologies of these Taiwan power electronics company?
Yeah, good question. Actually, these kind of players, but yeah, Delta, Laidan, Chiconi, Akabel, they are very well known because they are the main players in the planet for power converter industry. All of them are facing huge challenges for the future. They are facing AI demand, so they need to build a server power supply in order to feed the AI demand. So they need to search, and they are looking for some new chips, new solutions to feed this demand. And today, actually, to be honest, they are conservative. But it's okay. They have been working for the same semiconductor chip over the past 20 to 30 years with silicon chips. We are changing the way to make them much more innovation, and we bring this kind of innovation to them. So this is why we have a lot of education to make. I spend a lot of time here in Taiwan to meet people, to educate them, to tell them that we are helping them to move forward. And also one key information to grab, they are facing, this morning I made a customer interesting, Chiconi one. They are facing European challenges thanks to the whole regulation. They need to comply with their regulation. And today they face these challenges, and we are one of the key players to help them to bring more business in the future.
Any other questions? Yes.
So right now, when you do R&D, are mostly R&D done in France, or so basically in the office in Taipei and also in Hong Kong are basically sales and support offices?
For now, the R&D has been made in France. Our IP has been, let's say, explored and pop out from France. We are a spin-off company actually from CEA Research Center. Today, we are also expanding the opportunity and look for the opportunity to have much more open mind from other kinds of research center, from also new R&D center. Maybe Taiwan could be also in North America. So we are open for now to bring much more innovations because we see that there is a huge path on the way.
Okay. All right, so please give a big round of applause to Wise Integration for the pitch. And that's all for today's pitch session. And while the judges are tabulating the scores, we're now announcing that the second batch of the IC Taiwan Grand Challenge organized by NSTC has officially launched. So right now, we believe that our international and Taiwanese startup companies and startup teams are very eager to learn more about information and all the rules. So right now, I would like to welcome Ms. Guan Yiling, the section chief of NSTC, to share the latest competition information. Now, please welcome the section chief, Lin, to the stage. Welcome.
Thank you, ladies and gentlemen. Good afternoon. And first of all, I want to thank you all for joining with us to get to know all these amazing teams today. And I'm Karen, and thanks for having me. And before I jump into my presentation, I would like to share more further information with you about our main program here, IC Taiwan Grand Challenge, organized by National Science and Technology Council, NSTC. So first of all, I would like to talk about the background and the purposes within this program. We all know that 2024, this year, is a very special year for Taiwan because a lot of international leaders and CEOs of tech giants gather in Taiwan, like NVIDIA, AMD, and Applied Materials. And these people, they're talking about three same things. The first one, AI, artificial intelligence. And next is Taiwan. And the third thing is AI with Taiwan. I really mean it because we're actually, the whole world are stepping on the threshold on the fourth industrial revolution right now. driven by AI and chips. So since Taiwan lies in the center of semiconductor supply chain, we have to utilize our advantages and cooperate with more partners to facilitate or to build a brand new ecosystem with technology, talents, and industry driven based on chips to face more challenges in the next decade. So Taiwanese government have launched this IC Taiwan Grand Challenge to leverage the strengths of Silicon Island and to attract more international talents and investments to this island and to facilitate more innovations to come. And here are the topics we're looking for. Excuse me, the presentation doesn't move, so maybe to the next page. Okay, these are the topics we're looking for. There are two main categories here. Number one is IC design, and the other one is chip-based innovative applications. And the applications can be divided to 5 different domains. You can see that here, like smart data, mobility, manufacturing, medtech, and sustainability. Actually, these demands cooperate with or are fit in with our main policies in Taiwan right now. So if your products and solutions are in one of those domains, you are a startup or academic and research institute, or you are individual, you are very welcome to join the competition. And we will select the winning teams with those 3 main criteria. Number one is local connectivity and value creation and the technological innovation. And you can see that the local connectivity and the value creation take 40% way more heavily than the other one, because that's the spirit of this challenge. We will focusing on your plans, your goals in Taiwan, what you're going to do, and how do you achieve them with local resources, and then what are the contributions and welfare can it brought to Taiwan society. So this might be the most important slide in my presentation today. You might ask, what am I gonna get after so many hard works? Well, if you are selected, first, you will have a $30,000 prize when you arrive in Taiwan to receive the award. And second, you will have mentorship by our semiconductor industry experts. I'll show the list later. There are actually a worldwide, world-class masters. And we'll jump to number 4, resources. You will have various resources from our startup ecosystem in Taiwan to help you soft landing. And finally, if you are selected, you are qualified to join our IC Startup Accelerating Platform. And it is the biggest difference between this challenge and other startup competition. So Taiwanese government have formed this platform to integrate and to help those startups to realize their ideas and solutions with the support from Taiwan's very well-known companies, from prototyping to production. So you can say that it's a bridge to connect startups and industries in a more efficient way. So here are the list, and there are some of them are the judges today. And we have experts from industry like ARM, MediaTek, TSMC, and we also cooperate with international accelerators and industry association, R&D institutes, and also the local top universities. So if whoever you're going to connect or to cooperate in Taiwan, we can help you that. And these are the platform I just mentioned, which is we call the IC Startup Accelerating Platform. It integrates all the crucial resources, including EDA, IP, and IC design, system integration, and also wafer manufacturing, and from those very well-known Taiwan local tech companies. And we will help those winning teams to negotiate with these suppliers, and then case by case, and Taiwanese government will cover the expense, in which means that it's the best opportunity for startup to cooperate with these well-known famous Taiwanese company in the lower cost. But just a very quick notice here that funding resources will be in exchange of equity, because there's no such thing as free lunch, right? Especially it's government's investment, but it's negotiable. So we will help those winning teams to facilitate the process as soon as possible. And here are the other resources we have for the winning teams, like from our Taiwanese comprehensive startup ecosystem. We have 2 international startup bases here, TTA in northern and southern Taiwan. Actually, there are some of the teams who participate today are from TTA. And we also have connections with local universities. And also, if you are considering to open a branch or a headquarter in Taiwan, we have a specific office to help you that. So finally, the competition timeline. Actually, we just finished our first review of our first round several days ago. And the calling of our second batch have already begun on September 4th until January 1st next year. So there are still plenty of time for preparation. So if you are interested in our challenge and you are willing to cooperate with Taiwan to do something very big, you are very welcome to join with us to apply online with this QR code on our website. And also, if you have any questions, please contact us directly. So here's my presentation, and thank you all for having me, and hoping to see you guys very soon in the challenge. Thank you so much.
Thank you so much, Section Chief Lin of NSTC, for sharing the information of the IC Taiwan Grand Challenge. And right now, well, after a vigorous discussion among the judges, the results are finally in. So with that, I would like to welcome Dr. Conrad Yang, the chairman of the IC Taiwan Grand Challenge jury, to the stage to give us some comments and, of course, announce the results. Welcome.
Thank you, everyone, to join this event. This is also my first time I attend this event. Really appreciate it. We have 4 very strong teams from all over the world. The idea of IC Grand Challenge is trying to attract the world company to come to Taiwan to work with us so that we can help you to scale up to attack the global market. So the essential content really is not just how good you are, but how can we collaborate together to bring your company to a much, much better and bigger company. That's the idea. So I think after we have a discussion, some disagreement, but we reached a consensus, I think we select the first, second, and the fourth team to come to. The selection is really for you to enter the second phase. At least you pass the initial. We have a two step, and basically this is the first step for you to come to the final round for the second round. So I think the key really is because we have some discussion for 2 companies. For example, you have a very good instrument to measure it, and hopefully NTSC may help you to bring your tool here to help everybody, all the research, development, or semiconductor industry to utilize. For you, we try to get you more customer. For Taiwan, we also want to utilize this tool to help us better. So it's a win-win situation. For power, for gallium nitride stuff, I know you have been working with TSMC. So from the customer point of view, I don't think we can help that much. But hopefully with you can establish some research center for the better future, for your future development, and Taiwan can be one of your R&D hub to collaborate together, because we also have the power industry company to help you go together. So that's why we want you to come to the second stage, so that we can have a further, deeper collaboration to bring the company up. Okay? And the first company, the Blue Shift, I think is, generally speaking, we think is fit to this program, so hopefully you can come in. Actually, the third one, the Indian company, is also very good, but we think we still need to understand further how the Taiwan company and industry can co-work together, and that's the essential part of it. And we'll probably see if interesting, still continue to the next next challenge to enter the first round of the next challenge. So welcome and congratulations for the first, second, and the fourth team. Interesting enough, they are all from Europe. And Europe definitely is one of the area we think we need to focus on because we have been too much US-centric. I really want the Europe can become the next wave of high-tech hub. Okay, hopefully we can work together. Taiwan and EU all work together can help the global semiconductor industry. Okay, that's all I have.
All right, thank you, Chairman Yang. Please remain on stage. And meanwhile, we'd like to welcome the 3 winning teams to join us on stage. So please welcome Blue Shift Memory, Quantum Diamonds, and Wise Integration to join us on stage. And Chairman Yang, please present the sign as the 3 teams who can actually enter the second phase of the IC Taiwan Grand Challenge. Yeah, 2 for each team. And please take a group photo. Please give them a move to the left a little bit. Okay, all right. Oh, to the left? Okay, to the left a little bit. 1, 2, 3. Please give them a big round of applause. Whoa, thank you so much. Let's take a look at the photographer one more time. 我们摄影师有拍到吗？要不要再一张？有 ，OK， OK。Oh, okay. Can we have a thumbs up? Yay! Awesome! We say 赞 here in Taiwan. Awesome to the 3 winning teams. Thank you so much. And please remain on stage. We'd like to invite all judges and officials, our distinguished guests, to join us on stage for a huge group photo. And also all of the participating team. And would you like to join us? Yes. And the representative from Silesium Circuits. Do we still have? Okay, right here. Okay. All right, one more time. Can we have your thumbs up? Okay, please look at the photographer. Thank you. Please give a big round of applause to congratulate all the actually pitching teams. Thank you for your efforts, and thank you all of our judges. Thank you so much. And I would like to thank you all for attending today, for our distinguished guests on site and also online. Thank you so much for joining us here today at IC Taiwan Grand Challenge with SEMICON Taiwan. And we hope you can continue to follow TTA for more updates and hope to see you next time. Thank you and bye-bye our friends online. Thank you so much for joining us today at SEMICON Taiwan. Thank you.